Welcome back, dear students. Let's continue with exercise 12a. Today I am taking question number 13, which says in a triangle ABC, AD is a median and E is the midpoint of the median AD. Okay, so let's see the diagram here. So there's a triangle ABC. Okay, so triangle ABC is there. AD is the median. Okay, so AD is the median. So how do you draw median? So if you draw median from A, you have to go to opposite side. So opposite side is BC. So first find the midpoint of BC. So midpoint is this point, which is D. Now join A with the midpoint. This line is called the median. Okay, and E is the midpoint of AD. Okay, so this is my AD, isn't it? So E is this E is the midpoint of this line AD. Now a line through B and E meets AC at point F. That means a line through B and E means if you join B and E and extend it, this extended line meets this line AC at point F. That's what is the meaning. So you need to prove that AC is equals to 3 times AF. Okay, so AC is 3 times AF. That's what we need to prove. So here I have done one extra thing. Okay, so this thing is not given in the question. So what I have done here is, for help, we will draw a line DG which is parallel to BF. Okay, so this line DG is parallel to BF. Okay, now observe triangle ADG. Okay, so from triangle ADG we have triangle ADG is this particular triangle. Okay, now DG, you know, DG is parallel to BF, that is DG is parallel to EF, isn't it? And you know that E is the midpoint of AD, isn't it? E is the midpoint of AD. EF is parallel to DG. What does it mean? It means that this F must be the midpoint of AG, right? Using midpoint theorem, and AF must be equals to FG. And let me call this as equation number 1. Okay, now we'll observe triangle BCF. So let's see where is BCF. BCF is this particular triangle. Okay, now see, from this you know D is the midpoint. Since D, see, AD is the median means what? D is the midpoint of BC, isn't it? Okay, so D is the midpoint of BC, and you know that BF is parallel to DG. So using again midpoint theorem, I should say that G is the midpoint of CF, isn't it? So G is the midpoint of CF. That means CG must be equals to GF. Okay, let me call this to be equation number 2. Now see here carefully. Here also we have GF, here also we have GF. So if I combine these two, can you say that AF is equals to GF is equals to CF? Yes. And see here carefully. AC, this AC, can I write this as AF plus GF or FG plus CF? Can I do that? See here carefully. AC is what? AF plus FG or GF plus GC. I'm sorry, this is GC. Okay, be careful here. This is GC, not CF. This is GC. Okay, then it becomes from 1 and 2. Let's see what do we get. So from 1 and 2 we get, just wait a minute, this is not CF, just wait a minute, this is GF is equals to GC. Okay, this is not CF, this is GC. Okay, so here also you should write GC. So using 1 and 2 we can say that, see, AF is equals to GF, right, and GF is equals to GC, right? So that's why in place of GF can I write AF? Yes. Okay, and in place of GC, since GC is equals to GF and GF is equals to AF, so in place of GC can I write AF? Yes, so it becomes AF plus AF plus AF, which is 3 times AF. Okay, I hope the solution is clear to you. So you may pause the video and note down the solution. Let's have a look at this particular question. In triangle ABC, AD is the median and DE drawn parallel to side BA meets AC at point E. So let's see what is the meaning of this. So there's a triangle ABC, okay, AD is the median, and DE drawn parallel to BA. So this DE is parallel to BA, okay. So this DE meets AC at point E. That means this DE meets point AC at point E. Now we need to show that BE is also a median, okay. So BE, this part is also a median. In other words, I need to show that E is the midpoint of AC. Since if E is the midpoint of AC, then obviously BE becomes the median, isn't it? So let's see. Now in triangle ABC, AD is the median of BC, isn't it? AD is the median. Or in other words, can I say that D is the midpoint of BC? Yes, because AD is the median means D is the midpoint of BC, right? Now it is given that this DE is parallel to AB or BA and D is the midpoint. Now using midpoint theorem, can I say that, or by the converse of midpoint theorem, can I say that DE bisects this side AC? Yes, and in other words, it means that E is the midpoint of AC, isn't it? So that's why BE becomes the median of AC. That's why we say that BE is also a median. Okay, so you may pause the video and note down the solution. Let's have the last question for the day, and with this we close our exercise 12A. Okay, so let's see the solution of question number 17. In the given figure, so this is the given figure, M is the midpoint of AB and DE. Okay, so M is the midpoint of AB and DE. That means BM and MA, they are equal, and M is the midpoint of DE means DM is equals to ME. Okay, now whereas N is the midpoint of BC and DF. Okay, so N is the midpoint of BC and DF. That means BN and NC, they are equal. Okay, so this particular sign means they are equal, and N is the midpoint of DF means DN and NF, they are also equal. Okay, here we need to show that EF is equals to AC. Okay, so let's see where is EF. So EF is equals to AC. That's what we need to show. So let's see. Now in triangle EDF, so EDF, so basically they are talking about this particular triangle. Okay, now you know that M is the midpoint, right? N is the midpoint of AB and N is the midpoint of DF. Okay, so I'm sorry, in triangle EDF, M is the midpoint of DE, okay, not AB, this is DE, and N is the midpoint of DF, not DE. Okay, so that means since M is the midpoint of this and N is the midpoint of this MN must be parallel to EF, and this MN will be half of EF using midpoint theorem. So from here to the cross multiplication, you get EF is equals to 2 times MN. Now let's observe triangle ABC. In triangle ABC, see here carefully, M is the midpoint of AB in triangle ABC, isn't it? M is the midpoint and N is the midpoint of BC. So this is only correction that you need to make here is this one. M in this triangle, M is the midpoint of DE and N is the midpoint of DF. Okay, that's the correction that you need to make. So if you observe this, as I said, M is the midpoint of AB and N is the midpoint of BC. That means MN must be parallel to AC and MN will be half of AC. So from here, do the cross multiplication, you get AC equals to 2 times MN. Now call this as equation 1 and call this as equation 2. Here we have 2 times MN, here also we have 2 times MN. So from 1 and 2, what we can say is, we say that EF is equals to AC, and that's what we need to show here. Okay, so you may pause the video and note down your solution, and with this we conclude the first exercise on midpoint and its converse. Thank you very much.